Our company is a data intelligence as a service platform. We try to help companies adopt and scale AI-based solutions into their platform. And when we say AI, we don't just mean advanced AI, but it can start even with the base level analytics, which is descriptive and diagnostic insights. As you might be aware of, these are the 5 levels of analytics, and where descriptive and diagnostic are at the bottom of the chain, and then predictive, prescriptive, and cognitive analytics are the more complex types of analytics that many companies have challenges in scaling up from a pilot project into a productionized platform. So we help companies in this space by taking up any complex problem in any of these spaces, and then we do that through our I'm sorry. For some reason, the image doesn't show up here. But we basically do that through our platform, where we are able to ingest data in high volumes from using our API-based message broker, and then we process it through our analytic engine, and then deliver it through an API-based framework. So in this particular case, the context of this meeting, what we are trying to talk about is processing user-based content. So as we are all aware, there's a lot of user content being generated in different places. It could be product reviews or customer feedback or customer search requests, or even within platforms where users might be submitting search requests, or they might be submitting questions about their experience in the platform. What we are trying to do is, in order to improve the aspect of customer service, in order to more proactively feed the company about the sentiment being expressed by users, we need some kind of a sentiment analysis engine that's always running in the background, and then also processing the information that has been submitted by the users. So what we did is we took a data set from publicly available platforms like Yelp or YouTube, and what we did is, in this particular case, we took an example data set of restaurant reviews, and we took a certain amount of that data for training purposes, and then the rest of it for testing purposes. And we came up with a few visualizations, and also a sentiment analysis model that analyzes any user submitted feedback, and then provides the sentiment in it. So this is our platform where we provide all of the different types of insights that we create. We have domain-specific platforms. We have platforms for transportation, retail, e-learning, and in this particular instance, it's an NLP specific platform. So if you look at it, these are a few visualizations that we came up with. So this one, for example, is looking at the different types of ratings that restaurants received from their user feedback. So we were able to group the ratings into different types of numbers. So as you can see, we have certain amount of ratings in with 4-star ratings or 3-star ratings. And as we click into it, we see the drill down into how those ratings were submitted over time, average ratings. And this is a relatively small data set. This is they're basically restaurants in the city of New York. And as you can see, this particular restaurant has only like 1-star rating for a long period of time. And similarly, there we also have a word cloud-based visualization that is basically looking at the different types of reviews submitted and coming up with the analysis of the words in the word cloud. And you can see the words themselves have a breakdown of like the number of times they were mentioned in a positive context with a high rating versus a negative context in the low rating. Our platform allows you to chain together these different types of insights, and eventually we'll be having a whole library of insights, all rating around, all revolving around text processing and sentiment analysis. And users will be able to build up their dashboards in a similar fashion, and then look at all of them together. And these dashboards are interactive as well. So as I click into the different types of visualizations, the supporting visualization also will be reflecting like what that breakdown is. For example, here in this case, I clicked on this particular restaurant, and the rating that we see over a period of time is reflected here. Now, all of this data, some of this data was labeled for us, but then we also took a subset of the data, and then we applied our own algorithm to analyze the rating of that particular restaurant feedback. And the way we did that was by developing a sentiment analysis model. I have our senior data scientist on this call as well, and she might be able to throw some light on the type of model we created also. So, Swati, would you like to explain like what was the approach we took for the sentiment analysis model?
Sure, Sumant. Thank you. So for basically, this is whatever data we had. We had around taken a data of all the rest of around 49,000 reviews, and the first step which we did was basically regularizing the data set. In this, what do you mean by regularizing? Is using stop words. Removing the stop words, and then cleaning the data in terms of the words, like suppose like when a person writes a review, he generally there are certain instances where the person writes good and good, so that's g triple or four times o and d, whereas both refer to the same word. So in regularizing, all these kinds of errors, not errors exactly, these kinds of things are tackled in regularizing or cleaning the data set. Once that is done, then we build a library. So I have taken a library which is known as Glove 6B100D. This is a pre-trained model, and based on that model, I built a CNN model over here. So why I've taken a CNN model? Because there have been many papers written on classification, text classification, and CNN model has been known to do a good job when it comes to text classification. So with the help of CNN, we have built this model. And though the model has not given a very great accuracy, we got around 70% accuracy. uh, Going forward with more data set and the more advanced uh, NLP models like Spacey, or using the new one which has come up, which is Excelbert. So using all these kind of things, we could improve the accuracy of it. So the CNN model which I used basically had 32 filters in it, and we used a ReLU activation function with which the model was built.
Great, excellent. Now, thank you, Swati. Now I'm going to go into the demonstration of the model. So, the model is acting in the background. So, but we wanted to have an interface where we can demonstrate the performance of the model also. So this is a screen that we put together basically, and then I can go in and type something here. I can say this is a fantastic restaurant, and then I can say predict sentiment, and it's going to predict the sentiment as a 5-star sentiment here. So in the background, it's actually calling the model that Swati built. It's running on our platform, and it gets the result in real time. I can go and change this statement to something else, and I get a 1-star rating, so which is what we expect. Now, one of the ways where we actually test it also is like doing a comparative test. Like, for example, I go and find a restaurant that is close by, and then I randomly pick a review that was already submitted and see how our model performs. As Swati mentioned, this is only a 70% accuracy, so there's a chance that we get 3 out of every 10 submissions wrong. But there's also the hope that we get 7 of them right. So let's see. I'll go quickly and search for a restaurant nearby. And maybe I'll go to this one. This guy seems like he has good reviews. So I'll pick something here that is somewhat of a medium range review. Wow, doesn't look like he has any. Okay, I'll take this one. Let's see how this performs here. Cool. So you see, we got a 2-star rating here, and if you look at the restaurant here, that's a 2-star rating too. So luckily we got that one right. Let me try another one. Let me go to this guy, for example. Let me see this one. 1-star. Awesome. That was 1-star rating. So, so luckily in these two instances we got the responses right. So we are performing well within the result parameters. But we are constantly trying to improve this model, and we'll also hopefully get a better accuracy as we feed in more data, train more data, and we'll be testing the limits of this model also in real time as we start feeding in data. So as far as use cases go, this kind of a model and this kind of a platform is highly applicable for e-commerce applications or applications that have a high level of user feedback going through these platforms, and it can help them keep track of their the user engagement levels, how happy the users are, or how satisfied the users are with their product. And if they start seeing any patterns of negative sentiment, the clients can take a proactive action and then go and engage with the customers to improve their experience. So that's the value of a model like this and a platform that we have built. So we have a few minutes left over. So I'd like to see if anybody has any questions about this.
Yeah, I have a question.
Yes, sure.
Yeah, in terms of the sentiment analysis that you've just mentioned, I wanted to know more about, when it comes to good and good. So does that make a difference to your system? Is that about the impact of those keywords and whether the context of those keywords in terms of how strong is those people are trying to mention that word and so on, so that might make a difference in your dictionaries and so on.
Yeah, Swati, you want to answer that?
I'm sorry, actually got disconnected in between. I'm so sorry, Mr. Ali. Could you just repeat it?
I'll try to rephrase the question. So the question is that you mentioned the example of the word good with two O's and good with 3 O's, right? So Ali, you can correct me if I'm wrong, but the question is how much importance does are typos like that have in the result of the sentiment? What are we trying to do? Normalize the result.
Okay, so here we are trying to build a vocab. So vocab is basically a vocabulary wherein we are trying to find out the words which are used the maximum, get rid of the words which are not used much at all, like 1 or 2 instances where those words are used. Why we are doing this? So that we can build a vector. We can vectorize this entire tokens which are built, and based on the vectors we can come up with the similarity data sets, similarity words together. And based on that we can go ahead and build the model. That's the reason why it is very important for us to figure out the words which are mentioned as good or good, or words like pizza and pizzas, both are referring to the same word pizza. So for this reason is why we do the the regularization or cleaning up of this data.
Yeah, and one more question is that some keywords might have actually different meanings. So when you say like I like it, this is a phrase that means that you like something, but when you say it in a different context, you might be sarcastic, let's say. So that might lead to different results in the analysis. So how this your platform are is dealing with this dialogue?
So currently this particular model cannot identify sarcasm. So yes, there is a model which not a model. There's something known as computerized. Sorry, I forgot the word. Okay, there's a model which is people are been they're discussing, and there's research going on this for identifying sarcasm. But currently, the model which I have built has cannot identify sarcasm. That's one of the the pro cons of this model. It cannot identify the sarcasm which you mentioned.
But that is an important problem that many companies
Yes.
are trying to solve. Google recently came up with an algorithm that does the same thing. It does a context-based search, so that you can write something, but then it may not match with anything that's in your library, but it can understand the
Hmm.
context and come up with the result. So so
There
that's I
is.
think. Go ahead, sorry.
Yeah, so the one which I was mentioning was actually known as computational linguists.
Yeah.
So that model it digs deeper into the relationships between the words and how they are linked. Whether the sarcasm we are able to figure out in those words. So that is one model which I'm yet to work on. I'm yet to figure that out because there's a lot of research work going on that. So that is one. Yeah, that's one thing. And as
Yeah.
Sumant mentioned, Google is also coming up with another model.
Yeah, actually, I know that the model that Google shared previously about this topic, and I'm curious
Mm-hmm.
about this your platform. So
Mhm.
if there
Mm-hmm.
is a beta versions or something that we can try or test in order
Sure.
to so I will share my email in the chat so that you can send me more details. And we can talk about it later privately.
Sure,
Sure.
sure. Yeah, thank you, Ali. And yeah, as far as the platform goes, the way the platform is built, everything is modularized. So right now we are referring to the model that Swati built at the moment. But as we try to improve the same model, or we find better model that can have better accuracy or better contextual results, we can swap out the model that's on production with the new one, and then the platform should still continue to work as expected. That we have that level of flexibility in the platform.
Hmm. That's great.
Great, thank you. Any other questions, Ali?
No, actually, I'm good. Thank you.
Okay, great. Thank you for attending the presentation. We'll put up the recorded version of this in the Expo booth hub also, so that you can revisit this in case you want to look at any of this later on, or we'll be in touch with you
Thank you.
to answer any questions.
Definitely. Thank you so much and have a good day.
You too. Thank you.
Bye bye.
And Ali, there is an
Yeah.
upcoming presentation where we are talking about a natural language-based search also. So, if you're around, please feel free to
Yeah, I
join
will
that as well.
check. Yeah, me or one of my colleagues that can join.
Okay, great. Thank you.
Thank you so much. Thank you. Bye bye.
Bye.
Thanks.